Very good afternoon to one and all. So today we are moving on to one important topic from module number 4. So which are is under the title jigs and fixtures. So what is the need of these jigs and fixtures? It's a very important topic in manufacturing technology. Actually, this jigs and fixtures, they are special purpose tools which are used to facilitate the production when machined product are to be produced on a mass scale. Okay, or in other words, the products which are obtained from manufacturing processes such as casting, forging, etc. Sometimes the products obtained from these primary manufacturing processes which requires in order to obtain close dimensional tolerances, we need to go for some kind of machining. Okay, so by machining, um, yeah, you know that what is machining? You are removing the unwanted material from the products to get the final finished tolerances. So while doing the machining, here comes the importance of the jigs and fixtures. As I told you, they are the special purpose tools which are used to facilitate the production. How? See, when you are going to do this machining operation, so it is very important that the workpiece which is to be machined and this workpiece that need to be properly placed and clamped in a particular position so that the workpiece is not dislocated by the cutting forces acting on it. Okay, so what is jigs and fixtures and why it is needed? That's my first question. So for the easy understanding, I can say you the workpiece, in order to hold the workpiece or workpiece need to be properly placed and clamped in position or location. So why it is needed? So that the workpiece is not dislocated by the cutting forces imparted by the cutting tools. Why all this story? I told you in the beginning, you need to do the machining. Why? In order to obtain close tolerances. Why machining? Because the primary manufacturing processes such as casting, forging, etc., which leaves the workpiece with sometimes the workpiece with some undulations on the surface. So in order to get sometimes a flat surface or a specific requirement, you need to do the machining. So while you are doing the machining, in order to hold the workpiece well, here comes the importance of jigs and fixtures. Now, what is fixtures? What is a jig? So the fixtures, they are strong and rigid mechanical devices which enable easy, quick and consistently accurate locating, supporting and clamping. Okay, then what is a jig? Jig is also a fixture. It has an additional feature of guiding the tool, I mean the cutting tool, to accurate location where the machining is to be carried out. So that is a jig and a fixture. Often the terms jig and fixture are used interchangeably. There are clear distinction between these two tools. Both jigs and fixtures hold, support and locate the workpiece. However, a jig, as I told you, guides the cutting tool. A fixture references the cutting tool. So that would be the difference. A jig guides the cutting tool. That's an additional function. A fixture reference of the cutting tool. So the differentiation between this type of work holidays, I can also, please while you are hearing the lecture, please note the terminologies I am using. So the differentiation between these type of work holidays is in their relation to the cutting tool. So the jig guides the cutting tool, a fixture references the cutting tool. Maybe that would be a nice interpretation, I will say. Next, so while you are going to discuss in detail about the different jigs and fixtures, we need to understand one important aspect under this, that is the principle of location. The principle of location means the method of establishing correct relative position of the workpiece with respect to the tool. That is termed as the location. So I hope you are understanding, because we need to do the machining of the workpiece എന്തിന് to get the close dimensional tolerances as per the requirement of the drawing. Okay, so the method of establishing correct relative position of the workpiece with respect to the cutting tool or tool is termed as the location. Now let's look into some of the basic principles of the location. എന്തൊക്കെയാണ്? First one would be the location must be related to the or in par with the dimensional requirements stated in the workpiece drawing. നമുക്കൊരു വർക്ക്പീസിന് ഒരു ഡ്രോയിങ് ഉണ്ടാവും. Say for example 10 by 12 by 3. That would be a block you need to get. For example, a copper block. For example, and what you do, how you get the copper block first? Initially അതിനെ നിങ്ങൾക്ക് fabricate ചെയ്തെടുക്കണം. The primary manufacturing process, sometimes it can be a casting. You get it. Maybe when you get the casting, you always get the casting with the allowances provided. And what do you need to do? You need to do the machining. And in that stage, here comes the importance. So the principle of location means the method of establishing correct relative position of the workpiece with respect to the tool. That is termed as the location. Now, the first basic principle of location is it should be in par with the dimensional requirements stated in the workpiece drawing. Point number one. Point number two, it is preferable to use more accurately machined surface. So the second point would be it is preferable to use more accurately machined surface. So it is preferable to use more accurately machined surface than less accurate surface for location. So it is preferable to avoid bundulations, which I have mentioned before. The third point would be the workpiece, which is you are going to do the machining operation. Maybe the workpiece which you have obtained up after the primary manufacturing operations like casting or forging, which you are going to do the machining. So that workpiece should be prevented from the translational and rotational movements around XYZ axis, which means you need to do some restriction. Its movement has to be restricted. It has to be corded tightly. That what is the message. And the fourth point would be it should facilitate easy and quick opening and unloading of the workpiece. Next point, a redundant locator must be avoided. The locator which is used for locating the workpiece, if it is not useful, you have to avoid it, and should positively prevent wrong loading of the workpiece. Minimum locating point should be used while you are going to locate the workpiece for machining, and you need to ensure that you have used only minimum locating points. And last point, the locating surfaces should be perpendicular to each other to reduce the errors. These are the some fundamental principles for locating the workpiece for machining. Now let's look into while I told you the workpiece needs to be restricted. Its movement has to be restricted while you place it for machining, isn't it? Now let's see what does it mean. Yeah, you know that a workpiece in space can move in an infinite number of directions. So actually for the analysis, this motion can be break down into 12 directional movements. They are known as the degrees of freedom. I will explain it in detail. So for example, if you are going to consider the case of an object or a body, as I told you, it has the freedom to move in space an infinite number of directions unless its movement is restricted. If its movement is not restricted, it has infinite number of movements, isn't it? Am I right? Okay. So with respect to the three-dimensional coordinate system, you know, x, y, z coordinate system, we can define these movements as translational or linear movements which are parallel to the coordinate axis, that is x parallel to x-axis, y-axis and z-axis, and the rotations about the coordinate axes. So three linear movements and three rotational movements, isn't it? Am I right? Along x direction, y direction, z direction, and similarly the rotational movements. Which means the body has three linear movements and three rotatory movements with reference to the coordinate system. So if you look at this picture, a rectangular block is shown here. You can see a reference coordinate system x, y, z is placed at the corner. Isn't it? Am I right? Three translational movements and three rotational movements. Now we can say that what I can say, the body, this rectangular block has 6 degrees of freedom. It has a freedom to move in 6 directions, 3 linear and 3 rotational. That what is mean, degrees of freedom. It has freedom to move. Okay, so hence here the degrees of freedom means the freedom movement of the body with respect to the coordinate axes. Okay, now from this figure you understand that it has 6 degrees of freedom. Now let's have a close look at this rectangular block, or let's look at this rectangular block in more detail. I'm going to the next slide. Now if you look at this rectangular block, it can be said that this block has 6 linear movements along the 3 coordinate directions. I'm going to say this block, earlier I told you what are the, yes, positive and negative. If you take the x direction, positive x direction, negative x direction, positive y direction, negative y direction, positive z direction, negative z direction. Okay, so in addition there are 6 rotational movements too. How? Yeah, clockwise and anti-clockwise. Clockwise along x direction, anti-clockwise along x direction. Similarly for y and z direction. So I will say 6 clockwise and 6 anti-clockwise directions. So all these 12 degrees of freedom needs to be arrested for properly locating and clamping the block. When I was discussing about the principle of location, or when I was defined the basic principle of location, one of the very important point was you need to arrest the movement of the workpiece. എന്ത് സംഭവിക്കും അല്ലെങ്കിൽ ഈ വർക്ക്പീസ് കിടന്ന് ഇളകുകയാണെങ്കിൽ എന്ത് സംഭവിക്കാം? The machining will not be proper and it results in poor machining of the workpiece. So you need to hold the workpiece. It is all about that. Okay, so now from this diagram, now you know what you mean by degrees of freedom. So degrees of freedom endana? So means for the analysis, the motion of the workpiece is break down into 12 directional movements. That is called the degrees of freedom. It has the freedom to move in these directions. We are going to arrest all this or all the possible movements so that you can do the machining well. So that's the whole idea behind it. Now we are going to discuss one of the very important principle of location. It's called the 3-2-1 principle of locating. This has continuously asked as a university question in very different examinations. So As I told you, the 3-2-1 principle is a widely used method of restricting the 12 degrees of freedom. Okay, so a widely used method of restricting the 12 degrees of freedom is the 3-2-1 principle. So why it is called a so-called 3-2-1 principle? We are going to see it. Because it consists of 3 steps that employ 3 pins, then 2 pins, then 1 fixed pin of the known location. And since that add up to 6 fixed point, that is 3 plus 2 plus 1, it is also known as 6-point location principle. It is also called a 6-point location principle. Okay, let's see what does it mean. So if you look at this picture, a rectangular block is shown here, and this block is supported at the bottom surface. If you look at the bottom surface, you have a bottom surface, you have a side surface, you have a top surface. Okay, now the bottom surface, I'm going to explain the 3-2-1 principle of locating. If you look at the bottom surface, this block is supported at the bottom surface by 3 pins fixed over the flat surface. So you can see the bottom surface I marked as A, then B, then C. So the bottom surface of the block, or the block is supported at the bottom surface by 3 pins fixed over the flat surface. Okay, now let's define the degrees of freedom. Now some of the degrees of freedoms are arrested. Now with the reference to this figure, I can say that the linear movement along negative z direction is restricted, because I cannot push the block down, isn't it? That movement is restricted. And similarly, 2 rotations, that is one rotation about x-axis and y-axis, are also arrested, both positive and negative, I mean clockwise and anti-clockwise. So 1 plus 4, 5 degrees of freedom are arrested. Here the horizontal bottom surface of the block is a primary locating surface, and when it is placed about the 3 locating pins, 5 degrees of freedom are arrested. Now I'm going to provide 2 additional supports or locators on a plane perpendicular to the primary surface. So what is marked here as B. When you provide 2 additional support here, I will say 3 more degrees of freedom are arrested, which means this plane is called the secondary plane, and this 2 pin arrest one linear movement along minus x direction and 2 rotations about the z axis. 2 rotations about the z axis are also arrested. So apply 3, now total 5 plus 3, 8 degrees of freedom are arrested. Now I'm going to place a ternary plane perpendicular to the first 2 locating surfaces, that is A and B, which is marked as C in this figure, is provided with a single pin to support the block. The 6th locating pin, which arrests one more linear movement along negative y direction. So 5 plus 3 plus 1, total 9 degrees of freedom are arrested or restricted by the 6 locators. So clamping of the block restrict the remaining 3 degrees of the freedom. So total, by if you provide this 3-2-1 principle, you will be able to arrest all the degrees of freedom. So here the movements of the block are arrested by the 3 locating pins on the primary locating surface A, and 2 locating points on the adjacent surface B, and another 1 locating point on the ternary locating surface C. So which means the location of the rectangular block can be done using 3 locators or 6 locators or 6 locating points So this method using 3 to 1 locating points on 3 adjacent sides is known as the 3 to 1 principle of locating. അതായത് ഇവിടെ ചെയ്തിരിക്കുന്നത് ഈ 3 2 1 എന്ന പ്രിൻസിപ്പിൾ യൂസ് ചെയ്ത് ഈ വർക്ക് പീസിന്റെ കംപ്ലീറ്റ് മോഷനെ റെസ്ട്രിക്ട് ചെയ്തിരിക്കുകയാണ്. Though the 9 degrees of freedom are restricted by this method, when you clamp the workpiece using this technique, we can say after clamping you can see that all the movements gets arrested. So this is a very important principle. Say 3 to 1. While uploading this video, I am also will upload an animation video along with this, so that you will get a better understanding what I said using the theory. Okay, I will come with another lecture. Thank you.